This is a big theorem. Anytime they use the word theorem, it's a big deal. So this is your remainder theorem for your synthetic division. It says, if a polynomial, f of x, is divided by an x minus k, there's that x minus k I want to tell you about, guys, while we're changing the sign of the k value. If it's attached to the x, it's in the polynomial form of it. If it's got x on it, you want to change the sign of k whenever you take it out, because the negative in the formula changes k's sign. All right, so if you're dividing by an x minus k, then the remainder is the same as f of k. This is just magical. Whenever you see this in synthetic division, this is really a neat theorem. So watch this. We've got this polynomial, f of x, and we're going to do our synthetic division thing to it. It says find f of negative 3, which is equivalent to dividing by x plus 3. When it says find f of negative 3, that means the same thing as dividing it by, in polynomial form, x plus 3. So if it's written like this, the k value is already changed signs. It's already put the k value in there for the x. So anyway, don't change the sign if it's written like this. If it has the x on it, we change the sign.
Well, if it's just k equals.
And even if it just says k equals, if it's already taken off of the x, don't change the sign.
Don't change the sign.
Don't change the sign. All right, so we're going to plug in this negative 3 and do our synthetic division thing. Negative 1. Now notice they've skipped the third term, so make sure you put a 0 placeholder. Then 3, negative 4, negative 5. Then we do our little thing here. We bring the first term down, multiply, add your way across. Multiply, add, multiply, add, multiply, and add. That last number is the remainder. Now you're going to go through a series of homework questions where they'll say divide this and write the answer to the division. And so that would be down 1 from x squared. Negative 1x cubed, 3x squared, minus 6x plus 14, and then that's your remainder. Sometimes that's the question. In this case, though, the question is just find the remainder. Using the remainder theorem, it said, back up here, said the remainder is the same as f of k. Okay, so just wanting the remainder part. If it said find f of k, and this is what the question was, find f of negative 3. F of negative 3 equals the remainder, negative 47. All right, so if that's the question, only list the remainder. Just check it out with our old method for doing the function notation. If we were asked to find f of negative 3 back in the last chapter, what we would have done is plugged in negative 3 for our x's. So back in this original equation, we'd say negative 3 to the fourth plus 3 to the we plugged that in for the x, and it would have looked like this. And we would have done our arithmetic or used our calculator, and notice that comes out to be negative 47. So I can say that's just neat that the remainder theorem says that. It is just true if you do synthetic division that it is the same thing. The remainder is the same thing as plugging in that value for x. Now, why is that helpful to us in algebra and in this graphing section, besides just being a neat little theorem? It gives us a t-table value. If you were graphing, now you know f of negative 3, that's your x value, gives you an output of negative 47. That is a point on your graph. Okay? So that will be helpful to us when we get to the graphing of these. All right. Moving on. So next page, I've got a U-try for you. Let's do the second U-try. I think I used the first one in my example. So let's do f of x equals. And notice it just says find f of 2. When it just says find f of 2, it's just talking about find the remainder. All right, so go ahead, get that started, and we'll check it out.